Hey guys, welcome back to Algebra 3. Today we're going to look at 4.3 solving quadratic inequalities. So what these are going to look like, these are going to be something like x squared, something like x squared plus 3x minus 18 is greater than 0. And so they look similar to the problems that we used to do whenever we had, instead of an inequality sign, we had an equal sign. But now instead of an equal sign, we have an inequality sign. So we will start solving them very similarly. So we'll start by factoring. But do not, I'm going to say this now because this is where students usually make the mistakes, but do not set factors equal to 0. That's the main thing to remember for this entire lesson. C-E-R-O. So let's look at some of these and get started. So my first one is x squared minus 15x plus 50 is less than or equal to 0. So I'm going to start by factoring. So come over here, I'm going to copy down the problem, x squared minus 15x plus 50 is less than or equal to 0. Okay, then I'm going to factor, so parentheses, bring down the less than or equal to 0, and x, and let's see, two numbers that multiply to be 50, but add to be negative 15, maybe 5 and 10. And if they're both negative, negative 5 times negative 10 is positive 50. Negative 5x minus 10x is negative 15x. Okay, so it's factored correctly. Now here's what you don't do. Do not say that x minus 5 is less than or equal to 0, because that is breaking some algebra rules. If this were an equal sign, we would say, okay, well, x minus 5 equals 0, so then x would be 5. Cool. However, I can do that when there's an equal sign here because of the way that math works. Whenever you're multiplying and you get an answer that equals 0, then that would mean that either one factor is equal to 0, or both factors equal to 0, or both. So that's why when there is an equal sign here, we can set each factor equal to 0 and solve. That's not the case with what we have now. So let me change the problem back. Okay, right now I have an inequality. So what I need to do is I need to figure out what values of x are going to make x minus 5 times x minus 10 less than or equal to 0. So what I'm going to do is I'm going to make a number line. I'm going to figure that out. So what goes on the number line are zeros. In other words, if there were an equal sign here, what would the x be? Well, they're the opposite of what's inside the parentheses. So there is a 0 at the opposite of negative 5 is positive 5. And there is the opposite of negative 10 is positive 10. So you'll put the zeros on a number line, and then you'll test numbers inside the interval to see which numbers, when you substitute in for x, will give you an expression that's less than or equal to 0. So this is a number line. So it goes on forever and ever to negative infinity, and then it goes on forever and ever to positive infinity. So I've got it divided into 3 intervals, in between negative infinity and 5, from 5 to 10, and then 10 to infinity. So I can pick any number I want to in between negative infinity and 5. Let's go with the number 0. If you substitute 0 in for x, do I get a true statement? Let's see, 0 minus 5 is negative 5. 0 minus 10 is negative 10. And is negative 5 times negative 10 less than 0? No, it's not. So 0 or any other number in this interval is going to make that statement false. So not this interval from negative infinity to 5 is not the solution. Okay, so now let's move on to the second interval. Pick a number. Let's change this back to x's. Okay, now pick a number in the second interval between 5 and 10. Any number you want, any number at all. Let's try 7. Okay, so if I put a 7 in for the x here, and a 7 in for the x there, do I get a true statement? 7 minus 5 is negative 2. 7 minus 10 is negative 3. Is negative 2 times negative, oh no, 7 minus 5 is positive 2. There we go. Okay, so 2, positive 2 times negative 3 is negative 6, and negative 6 is less than or equal to 0. So the numbers in this interval make the inequality true. Now let's try a number in the last interval. So pick a number between 0 or 10, but from 10 to infinity. I'm going to try the number 11. If I put 11 in for the x here and 11 in for the x there, do I get a true statement? 11 minus 5 is 6. 11 minus 10 is 1. 6 times 1 is positive, which is not less than 0, so this is a false statement. So then, the numbers that make this inequality true are everything from negative 5 all the way to 10, and because it says or equal to, I'm going to include these values, and I include them with brackets. So my answer is bracket 5, comma 10. So bracket from 5 to 10. All right, now let's go into level 2. And level 2, it looks similar, but now it's not equal to 0. So you want to make sure that you are setting the inequality equal to 0 first. Not equal. Set inequality to have 0 on one side. So for this one, I'm going to subtract 9x on both sides. Then I'll do the same thing I did in the last problem. So now I'll have x squared plus 5x minus 14 is greater than 0. So I've got it greater than 0. Then I am going to factor. So x here, x there. Two numbers that multiply to be 14, but add to be 5. Let's try 7 and 2. Make the 7 positive, the 2 negative, because 7 times negative 2 is negative 14, and then 7x minus 2x will be positive 5. All right, so it's factored. Then I'm going to put the zeros on a number line. Make sure that you put them in order. They need to go in numerical order. So my zeros set, it's the opposite of what's inside the parentheses. So my zeros are negative 7 and positive 2. So I want to make sure I put them in order. So negative 7, positive 2, and my number line does go from negative infinity to infinity. All right, so I've got 3 intervals, an interval from negative infinity to negative 7, an interval from negative 7 to 2, and an interval from 2 to infinity. So let's go ahead and pick some numbers here. A number between negative infinity and negative 7, let's try negative 10. So if I substitute in negative 10 for x, negative 10 for x there, negative 10 plus 7 is negative 3. Negative 10 minus 2 is negative 12. and negative times negative is a positive, which is greater than 0. So the numbers in the first interval give me a true statement. Now let's pick a number in between negative 7 and 2. Let's try 0. Okay, so then I would have 0 plus 7 and 0 minus 2. 0 plus 7 is 7. 0 minus 2 is negative 2. 7 times negative 2 is not greater than 0, so this interval would be false. And then a number between 2 that looks like 20, but it's supposed to be infinity. A number between 2 and infinity, let's try 10. So let's try the number 10. 10 plus 7 would be 17. 10 minus 2 is 8. And 17 times 8 gives me a number that is greater than 0. So this last interval does make the inequality true. And I do have greater than, not greater than, or equal to, so I'll use parentheses instead of brackets here. So it looks like my solution is going to be everything from negative infinity until negative 7 with the parentheses, and then a parentheses because I just have greater than, not, or equal to, all the way to infinity. So then when I go to type in my answer, I'll have, let's see, parentheses, negative infinity to negative 7, and I'm going to use this union symbol because I need another set of parentheses. So parentheses 2 to infinity. Now let's look at this last section, quadratic inequalities when a is greater than 1. That just means our factoring is going to be a little more difficult. But it's nothing we can't do. Again, I've got to make the inequality with a 0 on one side. So for me, that means I'm going to be subtracting 5x on both sides from like terms, but notice there's no x, so I'll just have a minus 5x, and I'll subtract 1 from the like terms. So then that is going to give me an inequality that's going to look like negative 4x squared. Oh, you know what? I don't want my x squared to be positive. Let's do something else. Let's add 4x squared to both sides. Only to the like term. So I'll have a 4x squared plus 5x. And then I'm going to subtract 7. So now I'll have, erase that. Zero is, because 0 would be the one that's on the left, is greater than or equal to 4x squared plus 5x minus 7. And if we want the 0 to be on the right, I can rewrite it. I can say 4x squared plus 5x minus 7. Just have to make sure that's still pointing towards the inequality. So this time it would be less than or equal to 0. So now I'm going to go through and factor. Bring down the less than or equal to 0. To get 7, I'm going to start on the back. To get 7, I know I have to have a 7 and a 1. Then I just have to figure out factors of 4 that I can put in the front. So my factors of 4 are 1 and 4 and 2 and 2. So let's try a 1x and a 4x, and let's see what happens. 7 times a 1 will be 7. 28. No, that's not going to work. So let's switch the 4x and the 1x. Let's make this 4x and this x. So then I'd have a 7x and a 4x. Nope, that's not going to work either. Okay, let's try the 2 and the 2. Oh, hang on, I have a mistake. Go back. That's why it's not factoring, because I didn't subtract right. Okay, I forgot. Okay, so I have the positive 4x squared, positive 5x, but 1 minus 7 is not negative 7. 1 minus 7 is negative 6. There we go. Then if I want to write it with a 0 on the right, I'll have 4x squared plus 5x minus 6 is less than or equal to 0. Now let's try factoring. Okay, so let's try a 2x and a 2x to be factors of 4, and then to get a 6, let's try a 3 times 2. Let's see, 2 times 3 is 6, and 4 do not add or subtract to be 5. Okay, well, what if we make this a 6 and a 1 to multiply to get 6? That would be 2 and 12 do not add to be 5. Okay, so then let's try changing this to a 4x and a 1x. 4x and x, that would be 1x, and 24 is not 5. Okay, so let's try 2 and 3 again. All right, so now I have 4x times x to be 4x squared. 3 times 2 is 6, and then a 3x and an 8x could combine to be 5 if the 8 is positive. So 4x minus 3 and x plus 2. So now it's factored. I need to find my zeros, set on my number line. Okay, for the x plus 2, the opposite of positive 2 would be negative 2. And then for 4x minus 3, to find that 0, you're going to need to set the 4x minus 3 equals 0. So 4x minus 3 equals 0. Solve it, add 3 to both sides. 4x equals 3. X equals 3/4. So I've got a 0 at negative 2 and a 0 at 3/4. And so, and again, my number line goes from negative infinity to positive infinity, and I'm going to pick numbers on each interval, test to see if they make the inequality true. So let's test maybe negative 3. So if I substitute in negative 3 for x, I'll have 4 times negative 3 minus 3 times negative 3 plus 2. Now you don't always have to figure out, well, just kidding. Just forget what I said. Okay, so 4 times negative 3 is negative 12. Negative 12 minus 3 is negative 15. Times negative 1 is a positive number, so that's going to make this first interval false. A number in between negative 2 and positive 3/4, we could try substituting in 0. So let's substitute in 0. So that would end up being 4 times 0 is 0. So 0 minus 3. And then 0 plus 2. A negative times a positive would end up being a negative, which is less than 0. So this interval would be true. And then the last interval a number bigger than 3/4. Let's say 5. So 4 times 5 minus 3 times 5 plus 2. 4 times 5 is 20. 20 minus 3 would be 17 times 5 plus 2 would be 7. 17 times 7 is a positive number. I've got a false statement here. So the numbers that make the inequality true are the numbers in the middle interval, everything from -2 to positive 3/4. And because I have this line under the inequality, I'll put brackets around my answer.